Hello world, I'm Code Eric, and I'm working on Zerve. As you've hopefully been seeing, Zerve is an app that helps you manage data, and this is going to be a highly technical video and also a highly technical channel. So that's what we're going to be doing today, is we're going to be getting into some of the technical stuff. I want to show you what it's like in the Zerve codebase, and I'll give you a walkthrough of all of the different apps and all the different packages. And we can also do a little bit of a roast and a code review because it's just been me in here. I'm only going to be insulting my own code, and it's messy, which resembles what it's like in a real world code base. I like to call it, a young and active code base. It's a very fresh thing. There's lots of undocumented things and packages that are lying around that aren't really going to be used, but lots of things that I'm also really excited about and really proud of. And I think this product is coming along nicely. So oftentimes when the product is coming along nicely, the code base really suffers and kind of hurts. So hopefully this won't be too much of a dumpster fire, but I think let's just go have some fun taking a look at the code base. Here I'm in the code base, and I'm going to go open it up in VS Code as well. Now at our root directory, you can see that this is a TypeScript code base. So we've got a package.json, which is going to be the entry point for loading all of our content and packages and things like that. And it's also a turbo repo. It's a turbo repo, which means that there are sub packages. So there are a lot of package.jsons, and everything that's not this package.json is going to be a package that's inside of the apps folder or inside of the packages folder. So first, let's look at the apps folder. There are 3 apps that I really care about in here, and the rest I don't actually care about. But are useful for experimenting, and this is what it's like in a real code base. There's lots of sort of cruft sitting around all over the place. So the Z server is the API server that has all of the backend logic for Zerve. Z mobile is the app that you've been seeing. Hopefully it's a React Native app. I've got it pulled up, and I'll show you how to run it in just a minute. But it's located inside of apps/Z mobile. Z mobile, whatever we're calling it. There's an experiment called Live Mode Server. There's an experiment for Playwright, which is a browser automation system. There are some things in here that I was just experimenting with, and I wanted to keep it all in the same repo because I want to be able to share infrastructure across my projects. So there's a bunch of random stuff in here. PDF to HTML is an experiment that I was doing where you can extract HTML data outside from your PDF. It's just me testing out this little dependency, PDF to HTML. And I didn't wind up liking it, but I never wound up deleting the experiment from the code base. And so anyways, we can ignore all of the experiments. The things that we care about here are Z mobile, Z server, and Z web. And Z web, which I forgot to mention, is a Next.js app. It's the web front end for our Zerve. And I have actually kind of demoed Z web already, but it doesn't quite look right. So how do we launch any of these things? Well, in our code base, we're inside of our main place. So we can see that we have the package.json, and it's telling us that we have dev mobile and dev. So what dev does is it's going to start the server and the web. So it's going to be both of the web services running at the same time. And dev mobile runs the Expo server, the React Native server that will allow us to change our code and see the code on our iPhone. I'm going to skip over how I got this running on the iPhone, but it's just a normal Expo app, so nothing weird going on there. So I'll start the mobile app, yarn dev mobile, and then I would just go refresh it on the iPhone. You can see the Expo opens up in Chrome, and we'll come here and reload, and it's going to be running our new code. So what does the code look like inside of Z mobile? Well, we have a bunch of different folders. We have a folder full of components that are specific to the React Native app right now. Eventually, we might abstract these, but these are the components that are part of the React Native app. We have a folder called app, which has a bunch of logic in it, as well as the top-level app file. That's a little confusing. Like, this folder called app is kind of strange, but it has all sorts of other logic. For example, it has logic relating to internal history. So the React Native app is saving its history as it goes along. And a lot of this stuff has been implemented kind of recently. So I have good feeling about this code, but it does kind of duplicate a lot of the logic going on on the Zerve core. So now that you've seen what the three apps are, right? The three main apps for Zerve that we're working on is the server, is the web front end, and the React Native app. And all three of those are located inside of apps. Each of these depend on a bunch of logic inside of packages. And packages, as you can see, oh boy, there are a few packages here. And all of the ones that are considered Zerve packages that we might want to publish one day are prefixed with Z. So Z core is the one that depends on basically nothing. Z core has as few dependencies as possible, and the idea is behind Z core is that same code can be used on the web front end, on the web back end, and on the React Native app. So Z core is a folder filled with all sorts of useful or useless things. Some of these things are really critical in order to function. Like this Json Schema is one of my newer things, and this file is incredibly meta. In fact, I love this file because it's showing the JSON schema that we're using inside of our application. So this is the JSON schema that we're exposing to the user and letting them create their own JSON schema of this structure. But it is incredibly meta because here we have, this is an object that's describing an object that's describing an object, basically, which is a little bit crazy to think about, but that's part of the power of JSON schema, and that's why our React Native app is able to come in and edit the schema. Or rather, it's going to be able to create object schemas of its own from within the app. But we're not actually running the app properly. We can see that these aren't connected. They should be connected and reading the files that are on the local server. So something's not working. And in fact, it's pretty obvious, right? We haven't started the server yet. So we're going to run our servers with yarn dev, and you can see it starts up the web server on localhost 3000. So let's take a look at that in Chrome. And here it is. This is our web front end right now, which this does not look like the front end for Zerve. And the reason why is because we actually have a lot of catching up to do when it comes to getting the web front end caught up to where the React Native app is right now. Effectively, this is just a demo for the data that's here on the server. So here on the dev server, now we are able to load it up. We can tap on home banner and change the text. In fact, look, it's not even loading properly. So we're demonstrating a bug here. And this is what it's like when I'm in the code base for real and I'm not demoing it. The demos have been pretty curated and focused. And yeah, bugs are all over the place. So I'm not sure why it's not showing up here. Okay, so this is the demo that, I don't know if you may have already seen this demo where the website attempts to get it from the store, but it's not working. And if we look at the implementation of get from store, it's really got a bunch of stuff that's hard-coded. Like it should not be doing this where it's hard-coding in the URL. This, in fact, was just made very last minute so that I could have that demo working where it kind of looked like it was functional, but it's not actually functional. This is what it looks like behind the scenes. Pretty bad looking. This logic needs to be rolled in so that way the web querying logic is tied into the querying logic on the React Native side. So let's take a quick look at the React Native app because we've already taken a quick look before when I was demoing how the server works. The way the server works is through the system called Z, where all of this different logic can be strung together server side. But let's go ahead and jump into the mobile app and give a quick tour of the code base behind the app. Okay, so this app.tsx is the entry point for our React Native app. Here we're specifying that we've got a gesture handler, we've got the query provider, which allows us to use React Query. We've got the bottom sheet provider, which is actually, there's also a bottom sheet provider on each page. So this is really not ideal, or I'm not sure if this bottom sheet provider is working. There's the safe area provider, which is really important, so that way you're not rendering on the bezels and behind notches and things like that. And lastly, there's the navigation container and the root navigator, which is React Navigation 6. So the root navigator links to a special file called root navigator that has all of our screens defined. So whenever I'm adding a screen, I'm always coming in here to tell the navigation system, this is the screen component for a given route. So here we have all of our screen components defined, and we have a few different navigators. There's the root navigator and the settings navigator. I'll show you what that means. This is the root navigator, and when you're navigating between different screens inside of here, you're staying inside of the home navigator. So this is inside of the home navigator, and the root navigator allows things to come on top. So let's try the root navigator by navigating to settings. So now the settings navigator is on top of the root navigator. So again, like the root navigator, you can see has the home stack, which is kind of the base stack where all the screens are going when you're normally navigating through your data. And it has a bunch of other stuff, and it also has the settings stack. And the settings are all the settings screens, so you're going to be staying within the settings app when you're traveling between the different settings screens. So for example, when we tap on server connections, we're staying inside of this stack, and this whole settings stack is on top of the home stack. So if I want to get home from here, I don't necessarily even have to press back. I can just swipe away. So that's a quick overview of what the navigation looks like. I'll show you what it's like to actually use the navigation when you're linking from one thing to another, because we're using TypeScript and there's type safety, we actually need to have all of the params for every screen in our types. So I have a file called links, and this is where all of the type safety for navigating inside of the React Native app is set up. So here, these are all the different screens that we can go to inside of the home stack, and these are the arguments that we need to pass when we're going into a screen. Like when we go into the Z node screen, we need to pass in the connection and also the path of the node. So let's take a look, for example, inside of the Z node screen. The Z node screen, I'm not holding back, by the way. This is like a really ugly, complicated area of the code base. This is the screen that handles every one of the dynamic screens when you're inside of the dynamic API. So this is a Z node, and then you tap on something, and this is a Z node, and then you tap on something else, and this is a Z node. They're all handled by the same screen, and depending on what comes back from the server, we're going to be rendering something else. So here, because this is a container, we're rendering a container which contains these two other things. And state is a group, it's called a group, and dispatch is an action. So here, now because we're on this Z node, it's queried and said that it's an action, and it's also gotten the schema for the action. So now we know exactly what sort of values we're allowed to create when we're performing this action on our store. So that's the Z node. Let's take a look inside of it, because I kind of sold you short. I want to go quickly. I don't want to waste your time, but also let's see what it really is. So the Z node, the first thing you're going to do is query for it. So this is using React Query, and I've created my own query here, where you pass in the path. So for example, here the path is an empty array. Here the path is an array with store in it. And now the path is store and state, both in an array. So once we've queried for the data, we can get the type off of the data. And the type is here available on .t. So in this query, actually, this query isn't the most elegant thing. Now that I'm thinking about it, it's quite ugly because it used getTypedZ, where we have to go make two queries to the server at once. So every time you hit one of those pages, we are simultaneously asking the server for the thing that's at that path and the thing that's at the path with that specific type. And just to show you how well this lines up with the API, I want to show you how the app and the API are really demonstrating the exact same content. So here we have our API, and there's store inside of the API, and there's dispatch inside of, and at each one of those levels, we can also query for .type for the API. So here, let's go into Insomnia, our lovely Insomnia. Okay, here we have a basic query where we're getting the root Z. And here, again, it's listing the same things that it was with the app. It says there's the store and a few other things. Now we can query for Z/store, and now we can see that it has the state and it also has dispatch. So say I'm curious about dispatching. Well, when I get a action, this is what it comes back with. But when I get the .type, it actually tells me what is this Z. So that's what the Z API is doing behind the scenes in order to let the React Native app know what user interface should appear. It's exposing a .type endpoint behind each one of these endpoints. So for example, we have store/state, right? So this is actually getting the state inside of the store. It includes like our banner and the schema of these things. But we can also query for the .type of the state. And in this case, this type actually is not very good. It's a pretty abstract type. These are effectively any types, which are pretty dangerous in TypeScript and React Native. But basically, we need to have any types in order to build higher level abstractions. So that's what we're doing here. So that's the Z API, and that's roughly how the React Native app consumes the Z API in order to create this dynamic interface. And I want to demo a bunch of other features of the app, but mostly this is about the code base. So let me show you one additional thing about the code base before we wrap things up. Because in a previous demo, I showed how you can change the code of the server, and it would dynamically change the app itself. So let me open up the demo server. And I need to run the demo server by doing yarn workspace demo server. Okay? And let's make sure the demo server is working. It's available at 3999, and it has our calculator on it. So our demo server is pretty simple. What it's doing is it's providing a container, and it's providing a gettable and an action. Now, this calculator is being exposed to the client and being exposed to React Native, but we can also actually consume it on the server. Everything that's a Z is available both on the client, exposed when you create a server that has that Z, but you can also use it directly. So what if we wanted to perform an action, an add action? We can call into this action, and we can get this value server side. So right now it's actually kind of ugly because this calculator, it's not just an object that has value and add. It's a Z, so it has .z with it. So I don't know if I like this or how much this is going to change, or maybe I do like this and we'll just document this API and solidify it. But here, now we're actually accessing this action. So for the sake of TypeScript, I'm going to put this on a const, and we can see what TypeScript says. It knows that it's an action, and it takes in a number, and it returns a number. That's what TypeScript is effectively telling us right now. So here, we can do .call, and we need to asynchronously call. And here I'm going to try passing in a string just to show that hopefully it's not going to work. Oh, by the way, async, this is await. And here, the type safety is working here, and I'm just showing you that the type safety is doing what we want it to do, where a number, it needs to be actually a number. So we're going to pass in our favorite number, and we can see that the add action is going to return a number. So I think that's kind of amazing how we have this type safe function that's on the server, but it can also be exposed dynamically to the client. So if our client wants to come in to the server, they can go into server setup, tap on dynamic API, and have access to the exact same add function, including the full safety and the schema and everything. Again, I'm not hiding things from you. This is a bug. Look, we've been doing a sum with a number. It actually did allow a number to go through, and there is supposed to be validation logic. This action should be validated. So this would be a bug that I would file in a bug reporting system. But there are so many bugs in a code base like this, a brand new code base, I don't actually have a bug reporting system. I'm just constantly fixing as many things as I can. And I think it's a little bit more expedient that way. But yeah, I hope that this has been kind of an authentic look at what it's like in the Zerve code base right now. I want you to be hopefully entertained on a technical basis from what I'm doing here. You can check out the code base in the form that I'm demoing it. I'm going to provide a link in the description. And also, of course, you can see the code as hopefully it's gotten better and has progressed and cleaned up. So hopefully you've had some fun and this has been educational for you. Let me know what you think of the code base. Feel free to jump into it if you want. And let me know what you want to see next. I'll see you in the next one.